All right, welcome to the second part of the second lecture for descriptive statistics in Excel. This is where I'm going to walk you through some examples of frequency tables for categorical data and some other descriptive statistics for numerical data. So the first thing I want to walk you through is looking at the frequency table for categorical data. And I have a certain kind of data entered here in Excel. As you can see, I have age groups listed in column A. Specific, we've created specific age group categories here. And within each category, we have the frequency of patients total patients who live in the local hospital area. So we're looking at data for a particular hospital. So this hospital, there are 22,000 people between ages 0 and 17 who live in the local area. And then we also have the frequency in column B of number of hospital visits in the past year for people in that area. And what we're going to calculate is the incidence of visits per 100 patients. So that's a rate that I discussed during the lecture. We're going to calculate the relative frequency of total visits. And then also the percentage of total visits, which is another form of the relative frequency. We're also going to calculate the cumulative frequency or cumulative percentage, and then the proportional incidence ratio of new visits. So the first thing you should do in order to calculate these things when you get a table like this is you want to sum up the frequencies that are listed here across these age groups. So in order to sum something, you simply go to the formulas section up at the top, go to auto sum, go to sum, and it's going to create this box, and you want to sum from, just click here in B4 through B10. You hit enter, and that'll give you the sum. A little trick in Excel, if you want to copy a formula from one cell to another, you can just grab this little corner here and move it over. So now you can see we've summed not only total patients in the local area, but total hospital visits in the past year. Okay, so let's go ahead and calculate the incidence of visits per 100 patients. So this is a rate, but it's a rate per 100 patients. So remember, to calculate a rate, we have a numerator and a denominator. So put equals in the box, put an open parenthesis. Our numerator is the hospital visits in the past year divided by our denominator, which is patients in the local area. And this is per 100, so multiply that with the little star on your number sign on your keyboard by 100. And that gives you the incidence rate of visits per 100 patients, and you might want to round it to a reasonable decimal point. Here 2 decimal points is reasonable. To round it, you go up to this little section under the number, and you can decrease the decimal by hitting the arrow to the right, or increase it hitting it to the left. 2 decimal places is good. Again, if you want to copy this formula, you can simply just drag the corner of this box all the way down. It's automatically copying the formula for the other cells. So you can see we have the incidence rate of hospital visits per 100 patients in the local area by each of these age groups. If you want to get an example of the overall incidence rate, you just copy this box here. And so we're not dragging it down 1, we're taking it down 2. So you hit Control-C on your keyboard, click in the cell you want down here, hit Control-V, and this has given us the overall incidence based on the total numerator and total denominator. And so we have overall is 1.44. So the next question is, how do we calculate the relative frequency of total visits? And you may remember the relative frequency is a proportion of the count of observations in the particular category divided by the total number of observations. So in this case, that's equal to, we're looking at the relative frequency of total visits in the past year. So that's C4 here, which is the hospital visits in the past year for that particular category, and we want to divide it by the total N of hospital visits. So that is divided by this number here, this total number, so you can see why we calculated it. And so that gives us the relative frequency is 0.161. What does that mean? Well, if we want to do a percentage in column F, just multiply 0.161 times 100. It means about 16% of the total hospital visits were for people in the age group of 0 to 16. Now, I want to caution you here, when you want to copy this formula down, if you were to do that, it would assume, it assumes that as you bring it down, each additional it's copying from each additional row. So it would do that correctly for the numerator from column C4, but not for the denominator, because remember the denominator is always going to be the same. So one way of telling Excel that you don't want to change the denominator when you copy the formula is by putting these little dollar signs in front of the cell reference. So a cell is referred by the column name, which are the letters, and the row name, which are the numbers. And in this case, we want to fix the row. So we put the little dollar sign in front of the 12 there, and then we can just drag this down and copying it, and we get the relative frequency of total visits across these age categories. This column here multiplied by 100, we can simply drag it down, copy, and we get the relative frequency in terms of a percentage number. And so you can see those with the greatest percentage of the total visits in the population are those in the 36, 45, 46 to 55, and 0 to 17 categories. So another thing we might want to look at is the cumulative frequency, or cumulative percent is often interesting. So the cumulative frequency is pretty straightforward to calculate. It's simply, you calculate it in a direction. So in this case, we're moving the age groups. We're going from 0 to 17 to 65 plus. And it's simply, you're adding up the relative frequency of the previous categories. So for, we'll do it as a percentage here. For the 0 to 17 age group, there's no previous category. So it's just the cumulative percentage is 16. But when we go to the next one, we want to add up the percentage of those ages 0 to 17, the percentage of hospital visits for those, to the percentage of hospital visits for those ages 18 to 15. So what you do is you just add the previous cumulative frequency percentage in column G4 to the current category of interest, which is ages 18 to 25, to that particular percentage for them, and that's in column F5. So that gives that cumulative percentage. And now you can actually just copy this formula all the way down, because Excel's going to remember what you did. And so as you can see, when you move down to column G6, the cumulative percentage of visits for those from these three categories, ages 0 to 17, 18 to 25, 26 to 35, is 43. When you get to the last category, you should see 100. So everyone from ages 65 plus through all the other previous categories is people in our entire sample here, and so that's 100% of the visits. So the last thing I want to show you how to calculate here is the proportional incidence ratio. And so if you remember, the proportional incidence ratio is the number of observations with the characteristic of interest divided by some other denominator. And so in this case, let's look at the proportional incidence ratio of new visits. So think about what would be informative. Well, what about the proportional incidence ratio of hospital visits to the mean incidence in the entire population? So that would kind of give us an idea if there were more visits on average in that particular age group than the mean. So this is quite simply the proportional incidence that we're calculating here. The numerator would be the incidence for this particular group, in this case ages 0 to 17 in cell D4, divided by the mean incidence in the entire population here, which is this number that we calculated down here of 1.44. Again, we're going to put a dollar sign in front of the D12 so that when we copy the formula, we keep the denominator the same. And so what does this tell us here? There's 1.2. Well, this is telling us that the incidence of hospital visits per 100 patients for those ages 0 to 17 is 1.2 times greater than the mean in the overall population. And that kind of makes sense, right? Kids, especially little kids, go to the hospital more often on average. So let's copy this formula down. And so you can see the mean incidence ratio decreases until you get to age 26 to 35. And then as people start getting older, it increases because as people age, after a certain point, they tend to have more hospital visits than average. Okay, so that's how we calculate some of the frequency table statistics for categorical data. So now let's look at some descriptive statistics for numeric data. And I want to draw your attention to this table that I have up here in the upper left corner. You're looking at data on randomly selected 15 patients from a given hospital. In column A, we have a patient identifier. You would typically see this on individuals. And so this, in this case, it's just a simple number from patient 1 to patient 15. Column B, you're looking at patient age. So this is a continuous numeric variable. Column C, patient sex. Column D, you're looking at hospital stays. So total hospital stays in a year for that patient. Column E is the mean length of stay. So this is how many days did they stay in the hospital on average per stay. So for instance, for this person down here in cell D18, they had 8 hospital stays. Their mean length of stay per stay was 2 days. And then column F is the total cost of total hospital costs for that person across all of their stays. So pretty typical data you would see on hospital patients. So what I want us to do here is to calculate some of the sample statistics that I talked about during the lecture for numeric data. And we're going to calculate these on the hospital stays variable for these patients. So that's column D here. So the first thing we want to do is just calculate the sum of total hospital stays across all our patients. This is the sum of column D. You go up here to the formulas if you remember, go to the sum, and so in this case you're going to have to tell it you want to sum all the hospital stays. So that's from cell D4 through D18. So that gives us a sum of 46. Well, if you want to know the mean stays per patient, you can see we have 15 patients here, so the mean is simply the sum divided by 15, and so that gives us a mean of 3.07. If we want to know the minimum stays, well, you can see just by eyeballing the data here that the minimum number of stays is 1. I'll also show you a trick. You can let Excel tell you the minimum through this min function. You just have to tell it which column you want to look at. So in this case, we want to look at, again, the column with the hospital stays in it. So it'll give us what we already know, which is 1. You can do the same thing for the maximum down here. Let's do that. You could eyeball it, and we can tell the maximum's 8, or you could just use this max function. It'll give us the same number. So what about the 25th percentile? So if you remember our formula for finding the 25th percentile, it's the percentile number, 25, multiplied by our sample size, 15 plus 1. That product divided by 100 is equal to 4. I've already gone ahead and calculated that for you. So what does that mean? That means we need to go to patient 4, assuming we've sorted this in ascending order by hospital stays, which we have. Let me show you how to sort in Excel here. So if you want to sort, you got to select all the data, including the titles like I just did. Go to Data, click on this sort thing here. It's going to ask you what you want to sort by. Here we want to sort by hospital stays. What do we want to sort on? We want to sort on values in ascending order from smallest to largest. Click this little box here to tell it my data has headers. It's already sorted, so it's going to stay sorted like it is. But that just shows you how to sort data. Okay, so going back to the 25th percentile, we've identified that it's the 4th observation for patient 4 right here. Patient 4 is 1 hospital stay. So 1 hospital stay is the 25th percentile. The median, we've gone ahead and calculated that. So that's the median is the 50th percentile, which would be 50 multiplied by 15 plus 1 divided by 100. That's patient 8. That person has 2 hospital stays. The 75th percentile is patient 12 right here. That person has 5 hospital stays. And so if we're calculating the interquartile range, that, as you'll recall, is the 75th percentile observation minus the 25th percentile observation. So in that case, this is 5 minus 1. So our interquartile range is 4. We might also want to indicate in brackets what the 25th and 75th percentile range are. So that's 1 through 5. Okay. So now we're moving into where we want to calculate the variance. And so let's go back to our complicated looking variance formula here. Okay, here's our complicated looking variance formula. I have it circled in red. We want to sum up the sum of the squares here. So remember, take the mean, subtract it from each observation, sum it, or square it, then sum it, then divide it by n minus 1. So what do you get? So in order to do that, the first thing we needed was the mean, right? So we have the mean up here in column, we calculated at column M4. So then what we want to do is subtract the mean from each individual hospital stay. So let's do that here in column H. So we would insert the equal sign. We would do the individual observation hospital stays there for patient 1, column D4, subtracted by the mean over here in cell M5. Remember, we're going to put this little number sign here so that when we copy the formula down, it continues to look in that specific location. So in this case, we get a negative value. Let's copy this formula all the way down. And so because our data is sorted in ascending order as we go down, the value turns from negative to positive as some people have more than the mean. So the next step is to square this, right? Because we want to take the sum of squares. So to square it, as you remember, the power is simply the number multiplied by itself. So in this case, cell H4 times H4. So it's making these negative values positive. We copy the formula down here, and so we get the square of the individual observation with the mean subtracted. So the next thing we want to do is sum it, right? We want to sum this up right here. Oh my gosh, I have you looking at the standard deviation formula. Let's go look at the variance formula. So same thing, we want to sum this up right here. So that's pretty easy. We know how to sum. We go to the auto sum here, select sum, and we want to tell it to sum these square values right here. And there we go. We got the sum of squares. So it was a complicated looking formula. Pretty easy to do in Excel though, as we just saw. So the next part of the formula is n minus 1 patients. Well, we have 15 patients minus 1. That gives us 14. Okay, so now we're ready to calculate the variance. And the variance is simply the sum of all the squares divided by n minus 1. So that is the sum of the squares here divided by n minus 1 here. And bingo, we got the variance. It's 4.5. So now we do the standard deviation, which is this complicated looking formula, but once we got the variance, all we have to do is take the square root of it. So Excel will actually give you the square root of any number. And you go to this Formulas tab here, Insert Function. You want to type in SQRT, go. Excel is a square root function, click OK. And what it's asking you for is the number or the data. And so you just click this cell reference here, OK. Square root of 4.5 is 2.12. All right, so now we have both the variance and the standard deviation. Next step is for us to calculate standard error of the mean, which is the standard deviation divided by the square root of n. So let's find the square root of 15. We go to our function here, type in square root. Here, let's just enter the number 15 because that's our sample size here. We got the square root of 15, 3.87. So the standard error of the mean now is quite simply our standard deviation of 2.12 divided by the square root of n, 3.87. And we got the standard error of the mean, which is 0.55. Okay, what about the coefficient of variation? So that's this formula here, which is the standard deviation divided by the sample mean, and then you multiply that by 100. So we put it in brackets here to set up the order of operations. Standard deviation of 2.12 in cell M15 divided by the mean in cell M5. Close the parentheses, and now we want to multiply by 100. And there we go. We have the coefficient of variation, which tells you on a relative scale the degree of variation in the data. And now we have all of our descriptive statistics.